Hello students, welcome back to my channel NJ Math World. Today I am here to solve second semester BCA question paper October-November 2022 final exam. The paper code is DCCA 203 and the subject is discrete mathematical structure. So the time duration will be 2.5 hours. Maximum marks will be 60. We need to answer all the sessions. Session A contains 2 mark question. In that 2 mark, we have to answer any 6. So the question number 1 is, what is proposition? Give an example. A proposition is a declarative sentence which is either true or false, but it cannot be both. Example, 3 is a prime number. The statement is true, therefore it is a proposition statement. In how many ways 4 boys can be seated on a bench? So we have n will be 4, total number of benches. Total number of boys are 4. So number of boys that can be seated can be written as R will be 4. So we have a formula npn is n factorial. So here we get 4p4, certainly 4 factorial. 4 factorial is nothing but 4 into 3 into 2 into 1. We need to write it in reverse. Factorial means we should write the number in reverse order. 4 3s are 12 into 2 1s are 2. So 12 into 2 is 24. So we can arrange 4 boys in 24 different ways to sit on the bench. The next question is state principle of mathematical induction. So here mathematical induction is a technique or a method which is used to prove mathematical statement, formula, theorem which is though to be true for each and every natural number of n. So this contains 2 steps. So step 1 is basic step and step 2 is inductive step. Fourth question is give the truth table of implication. So implication is P, Q. So it is true, true, false, false. So really true, false, true. So implication is nothing but represented as P implies Q. So here in the condition for P implies Q, implication is whenever it is T and F, the answer will be F. Else the answer will be true. Only when it is T and F, it is F, otherwise it is true. Is a truth table for implication. Then we have fifth question is find the symmetric difference of the given set 1, 3, 5 and 1, 2, 3. So here A is 1, 3, 5 and B is 1, 2, 3. So here we need to find the symmetric difference. Symmetric difference is represented as del A symmetric B is given as A minus B union of B minus A. This is a formula to find the symmetric difference. Certainly A minus B is nothing but A by B union of B minus A is B by A. So here A is 1, 3, 5 and B is 1, 2, 3. And here it's union of 1, 2, 3 divided by 1, 3, 5. So now the like terms will get cancelled. So it is 3 and 3 cancel, 1 and 1 cancel. So the remaining which is there in the numerator will be your answer, that will be 5. Then union of, same way the like terms will get cancelled. What is remaining in the numerator only we will be considering, so it is 2. Therefore union of 5 union 2 is 5 comma 2. So this is your symmetric difference of the given set. Going with the next question. What is a null set? Null matrix. Give a example. A square matrix is said to be a null matrix if all its elements are 0. So here square matrix is nothing but number of rows should be equal to number of columns. So here I am drawing. Here we have 1 row, 2 rows, 3 rows. So rows are 3 and columns are, standing lines are said to be column. So here number of columns are 1, 2 and 3. So columns are 3. So it can also be written as M cross N. Okay, M and N. So we write M cross N. So it is, the order of this matrix is 3 cross 3, that is nothing but a square matrix. When M and N are equal, it is called a square matrix. And when all the elements of the matrix is 0, then it is called as null matrix. Then diagonal matrix. Give an example. A square matrix is said to be a diagonal matrix if all the elements are 0 except the principal diagonal element. So yeah, square matrix principal diagonal element is nothing but the elements which are there in this place. So here I can write, so here let it be 1, 3, 5, anything, you can write any number. So I am writing it as 1, 3 and 5, 1, 3 and 5, and the remaining will be zeros. The remaining all the elements will be 0. Then it is called as diagonal matrix. It is a square matrix, again we have 3 rows and 3 columns. So diagonal matrix is nothing but it should be a square matrix and all the elements of principal diagonal should be present and other element should be 0. Then it is called as diagonal matrix. Then we have defined graph isomorphism. Isomorphism is nothing but if two graph is given, if two graph is given and in that two graph number of rows are equal to number of columns, so number of vertices, the in both the graph the number of vertex should be same. That means, so this is graph 1 and this is graph 2. So here it says what is a isomorphic graph. It is says first condition is there will be an equal number of vertex. Vertex is nothing but what? It is a points. So we have here 1, 2, 3, 4, 4 points in this. Vertex is 4 and here we have 1, 2, 3, 4. So here also we have 4. So vertex should be same. Then it says number of edges are same. Edges are nothing but lines. So lines are same. 1, 2, 3, 4, 5, 6, 7. So we have here edges are 7 and here we have edges 1, 2, 3, 4, 5, 6, 7. Even here we have 7 edges. Then their amount of degree sequence are same. So degree sequence is nothing but counting the lines which is joining to this point. So here we have 1, 2, 3. So till 3. Here it is 1, 2, 3. It is 3. For this it is 1, 2, 3. So 3 lines are touching here. 3, 4 lines are touching. So till 4. So here it is 1, 2, 3, 4. So till 4. So the degree sequence will be what? It will be 3, comma 3, comma 4, comma 4. So here it is degree sequence. So same way here for this, you have 1, 2, 3, 3, then 1, 2, 3, 4, it is 4, 1, 2, 3, 4, it is 4, 1, 2 and 3. So here again the degree sequence will be 3, comma 4, comma 3, comma 4. You can see sequence here we have 3, 3, 4, 4. Here also we have 3, 3, 4, 4. Therefore the elements present inside in the sequence are same. Therefore the two graphs G1 and G2 are isomorphic. Then moving on with the next one, find the adjoint of A. Adjoint of A is very simple to find for 2 by 2 matrix. So here the given matrix is 2 by 2 matrix. It is 2, 1, 5 and 3. So how to find the adjoint of 2 by 2 matrix? It's very simple. Say adjoint of A will be We need to interchange these elements. That will be 3 will go up and 2 will come down, and we need to change the sign for these elements. Certainly -1 and -5. So this becomes the adjoint of A. That's it. Then moving on to the next question. So section session B, it consists, we have to answer any four. Each question carries 6 marks. So here we have a 10A. First part of 10th question. First sub question is, write the converse, inverse, and contrapositive of the conditional statement. So here let us consider P as the home team wins. Then we'll take Q as, we'll break the sentence into two. Whenever it is raining. So now this sentence we are going to change into converse. What will be converse? Converse is nothing but Q implies P. Means that will be whenever whenever it is raining, whenever it is raining, the home team wins. Then next one is inverse. Inverse is negation P implies negation Q. Negation means the home team do not wins whenever whenever it is not raining. So we need to add not if it is negation for both the sentence. Then it is here, this is converse, this is inverse, and the last one is contrapositive. Contrapositive. Contrapositive is negation Q implies negation P. So here reversing this answer, whenever whenever it is not raining, we have to reverse this. The home team do not win. So this is converse Q implies P, inverse negation P implies negation Q, contrapositive negation Q implies negation P. Now let us solve the question number 10. Construct the truth table for the given composite propositions. So here they have given P, Q, R. So here P, Q, R is, we'll write like this, T, T, since it is 3 elements, that will be 2 to the power of 3. So it will be 2, how 2? One is true and one is false. So it is 2 values and 3 variables. We have a 3 preposition statement. So it will be 2 power 3, that will be 8. So for 8 we will divide into 4. 4 times T and 4 times F. Then Q it will be TF, TTFF 2 times. 2 times T, 2 times F, TTFF. Then for the last one, it will be 1 time T, 1 time F, TF, 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 TF. So it will be 4 and 4, then 2, 2, 2, then 1, 1, 1. Then here we have, first you should do the bracket, what is given in the bracket. Q and R. Q and is nothing but a conjunction. What is for a condition for conjunction? If it is T and T, it is T. T and T, it is T, otherwise it is false. So we had only T and T. We have to check it in this 2. T and T it is T. Then we have here T and T it is T. Then again we have only for 2. The remaining all will be false. Then next you will take P, R, Q and R. So here we have to check for P line and Q and R line. So here we have condition is OR. OR means it is if for AND it is T and T it is T, otherwise it is all false. Then for OR condition is F and F it is F, otherwise all it is true. So here we'll use that formula P and it is T and F it should be F. So I don't have first one, second, third, fourth, fifth. Fifth is F and F F. Sixth is also F and F F. Seventh is also F and F F. The remaining all will be T. This is only how you construct the truth table. Now moving on with the next part B. B is given as again P, Q, R. P will be how much? 4 times T and 4 times F. Then Q will be 2 times T, 2 times F. 2 times T, 2 times F. Then R is 1 time T, 1 time F. Now we have, first you will solve first bracket, P or Q. Or is what condition? F and F, F it is F, else why it is true. So we'll check it for P and Q means first and second line. That will be T and T it is, we will check for the condition. F and F it is F, F and F it is F. Otherwise all are false, all are true. So next one we have P or R. We have to check it for first one and third one. We'll check for the condition or is nothing but F and F it is F. F and F it is F. F and F it is F. F and no, we don't have. F and F it is F. You have to check in the first and third line. The remaining all will be. Now we need to check for this both. That is, I'll call this as 1, I'll call this as 2, 3, 4, 5. Now we have to check for 4 and 5. We have to check in these two lines which we have. That is here for AND it is T and T it is T, 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 T and F it is F, T and F it is F, T and F it is F. So you can check with this, we can see that first and A and B are equivalent. That is same. They are same. Okay, similar. Then next one. You have 11th one is 11th one is the function f of x equals x plus 1 is the set of integer to the set of integer is 1 1. So we have to check whether it is 1 1. How to check 1 1? Let x1 comma x2 belongs to R integer, that is z. Then f of x1 will be equal to f of x2. So here f of x1 is x plus 1, that x plus 1. So this side I have 1, this side I have 2. Then this 1 and 1 get cancelled, we get x1 equals x2. Therefore f of x is 1 1. Then you have next one is find the Find how many ways the arrangement can be done with the letter mathematics. So we have a letter mathematics, MATHEMATICS. So here count how many numbers we have alphabets: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it will be 11 and 11. So 11 letters are there. So it will be 11 factorial divided by how many are repeated. We have to find the repetition of the letters. So M is repeated. So it will be 2 factorial 2 times. A is repeated. It is repeated 2 times, 2 factorial. Then T is repeated 2 times. It is 2 factorial. So it will be 11 factorial means 11 into 10 into 9 into 8 into 7 into 6 into 5 into 4 into 3 into 2 factorial divided by 2 in factorial 2 into 2 into 2 factorial. 2 factorial cancel, 2 2s are 4 and this 4 get cancelled. So if you multiply the values, we get answer as 4989600. So this many ways we can arrange the word mathematics. Then the sub question, the second question says, in how many of them the vowels occurs together? So here, how many vowels we have in mathematics? We have A, E, A, I. Vowel is nothing but A, E, O, U, I is called vowels. In letter mathematics, we have this many vowels. Then you have M, T, H, M, T, C, S. Mathematics. So here we'll consider this whole as 1, 2, 3, 4, 5, 6, 7, 8. So total we have 8 letters. If you take vowels together, then you have M is there repeated. We take M 2 factorial and T is repeated here. Certainly 2 factorial. So we are considering this as 1. So we will not take a value. So it is 8 into 7 into 6 into 5 into 4 divided by 4 into 3 into 2. Certainly 2 factorial into 2 into 1. That is 2 and 2 get cancelled. 2 ones are 2 twos are. When you multiply these values, we get 10080. Then we need to do it for vowel separately, that is A, E, A, I. So in this we have 4 letters, that will be 4 factorial divided by A is repeated, so it will be 2 factorial. So it will be 4 into 3 into 2 factorial divided by 2 factorial. 2 and 2 get cancelled, 4 3s are 12. So to find the vowels occurs together, therefore the vowel occurs together will be multiplication of this both answers what we got into 12. That is nothing but 120,960. 1,20,960 ways. Then we have next question is, in how many ways can a football team of 11 players selected from the 15 players? How many of these will include one particular player, exclude one particular player? So first let us say there are 11. So yeah, the number of ways of selecting 11 players 11 players from 15 players can be given as 15C11. So now 15C11 is very difficult, like it will take time to solve, so we will simplify 15C 15 minus 11. By using the formula we have NCR is NCN minus R. So it becomes 15C, 15 minus 11 is 4. So we need to write 4 numbers of 15 in reverse order, 15 into 14 into 13 into 12, and then divided by the number 4. What we have to write the factorial of that, 4 into 3 into 2 into 1. So it will be 4 ones are 4 threes are, then 3 and 3 get cancelled, then 2 ones are 2 sevens are. When you multiply 15 into 7 into 13, we get the answer as 1365. Then the sub question 2 is given as including one particular player. So the condition 1 we can write, first condition is given as if one player if one player is always included. If it is included, what we are going to do is we'll minus 1 from n, that will become 14, and 1 from r, it will become 10. So it will be 14c10. That can also be written as 14c 14 minus 10, that is 14c4. That means 14 into 13 into 12 into 11. Only you'll write 4 elements in reverse order for numerator, and then 4 is there means you should write it 4 into 3 into 2 into 1 factorial. 4 threes are 12 and 12 get cancelled. 2 ones are 2 sevens are 14. So when you take 7 into 13 into 11, we get the answer as 1001. Then the next one is if it is included. Second sub question is if one player one player is always exclusive excluded, then we write it will be n will be 14, but r will be n will be 14 and r will be 11. We will be removing 1 from the total. Excluding means 1 will not be there. Then it will be 14c11. That can again be written as 14c 14 minus 11. That will be 14c3. That will be 14 into 13 into 12. 3 numbers divided by 3 into 2 into 1. So this will be factorial, 3 into 2 into 1. 14 we have to reverse 3 numbers because it is 3 in the r place. Then it is 3 ones are 3 fours are, 2 ones are 2 twos are. So when you multiply 14 into 13 into 12, 2, we get 364. So hence it is solved. So next question is show that for the following n is not greater than or equal to 1. They've given a square plus 2 square plus 3 square plus goes on till n square is equals to n into n plus 1 into 2n plus 1 divided by 6 using mathematical induction. So what we are going to do is we have many steps here. So step 1 will be whatever is given, we'll call it as p of n. Then first step we'll take n is equals to 1. So here p of 1 will be 1 square plus 2 square plus 3 square goes on till 1 square will be 1 into 1 plus 1. Wherever you have n, we'll write it as 1. 2 into 1 plus 1 divided by 6. We'll just consider the last value to leave 1 equals 1 into 2 into 2 ones are 2 plus 1 is 3. So divided by 6. 2 threes are 6 and 6 get cancelled. 1 equals to 1, that is LHS will be equal to RHS. If both are equal means P of 1 will be true. The step 2 will be step 2 is we'll take n is equals to k. Let n is equals to k. So it will be P of k equals 1, that is 1 is to 2 is 2 square, 1 square plus 2 square plus 3 square plus k square will be equal to k into k plus 1 into 2k plus 1 divided by 6. So therefore P of k is true. Now Step 3. We shall prove P of k plus 1 is also true. K plus 1 is also true. To do P of k plus 1, we should not write in place of n as k plus 1, but we have to solve it. How do we solve P of k plus 1? It's simple. See here. If you take the number integer, if it is 0, till minus 1, minus 2, minus 3, and here comes 1, 2, 3, 4. So here this arrangement of number is in the form of integer, that will be, this will be n. So here it will be n plus 1, n plus 2, n plus 3, and it goes on. And the LHS is n minus 1, n minus 2, n minus 3, and so on. So this way the arrangement of the numbers are given. So to find for n p of k plus 1, what we need to do is, whatever term we have here, we have to take the next term of that. If it is n, what will be the next term of n? It will be n plus 1. So we'll be adding that next term in RHS and LHS, and we will simplify to find k plus 1. So here we will write p of k plus 1 equal, that is 1 is to 1 square plus 2 square plus 3 square plus k square. So we will be adding the next term which is there in place of n. What is next term? N plus 1. So it is k, means it will be k plus 1 whole square. So whatever I am adding it to the LHS, the same value I will add it for RHS. That will be k plus 1, 2k plus 1 divided by 6 plus k plus 1 whole square. Whatever I am adding for LHS, same term should be added in the RHS. Now we have to simplify this term to get the value of k plus 1. So here we take k plus 1, we can take it as common, and it will be k 2k plus 1. If I am taking LCM, cross multiplication, it will be 6 into k plus 1. Since I have taken k plus 1 common, here square it will become k plus 1, and here this k plus 1 I have written out, so it will be k into 2k plus 1 divided by 6. So now if you simplify the terms which are there inside, it will be 2 into k into 2k is 2k square, plus k into 1 is k, plus 6 into k is 6k, plus 6 into 1 is 6 divided by 6. Further simplifying, we get k plus 1 into 2k square plus 1 plus 6 is 7k plus 6 divided by 6. So this divided by 6, I'll take it outside, k plus 1 divided by 6. Now simplifying this in the form of factorial, that is factor form, we get, I'll do it here, that is 2k square plus 7k plus 6. If I take the factor for 6, it will be 2 into 6 is 2 6 are 2 6 are 12. Find the factor for 12. It will be 3 and 4. 3 4s are 12. So it will be plus 3 and plus 4. So the same thing we can write it in the form of 2k square plus 7k. In place of 7k, we'll write 4k. This answers what we got. 4k plus 3k plus 6. Taking the common factor in this, we get 2k. That will be k plus 2 plus, if I take common 3 here, it will be k plus 2. So yeah, whatever terms are there outside, we'll write it in one bracket. That will be 2k plus 3, and what is there repeated, it will write it one time. That will be k plus 2. So this will be the answer here. So I'll write that answer. So I got here, simplifying, I get 2. I'll write it as k plus 2, and then it is k plus 2, k plus 2, and then it is 2k plus 3. Now, whatever answer we get, it should be similar to the question, but in place of k n, it should be k plus 1. So we'll rewrite this and write it as k plus 1. Then k plus 2 can be written as k plus 1 plus 1. 1 plus 1 is 2. So I'm just breaking it and writing, spreading it. Then here I'll take 2 common. It will be k plus 1. So when I multiply 2 ones are 2, and here I have 3. 2 plus 1 will give us 3. So if I remove the bracket, I'll get back the same terms. Whole divided by 6. Now if you compare this with the question what we have, that is k, n, it will be n to k plus 1, k plus 1, and here it is n plus 1, 2 k plus 1 plus 1 divided by 6. This and the question what they give should be similar. Therefore, P of n is true for all positive integers. All positive integers. Therefore, P of k plus 1 is also true. Hence, it is proved. Uh, then moving on with the next question we have. Solve using Cramer's rule. So what we are going to do for Cramer's rule? So yeah, first let me convert the given linear equation in the form of matrix. So it will be A matrix A will be 3, 2, 1, 1, 2, minus 3. This is 3, 2, nothing is there means 1. No number means 1, plus 2, minus 3. Then no number means 1, plus 5, 1, 5, and then minus 4. This will be your B value. Then we need to find what is given solution. That's the B will be 3 minus 1 and 2, 3 minus 1 and now we need to find a Cramer rule means first we should find the value of delta, determinant of A, that is delta. Delta is nothing but it's in the form of determinant, that will be 3 1 1 2 2 5 1 minus 3 minus 4. So yeah, we will take the values as plus minus plus. So I'll be taking the first term to find the determinant of it. So it will be plus 3, and the terms which is left out will be 2, 5, minus 3 and minus 4. Then it will be next one. I'll take the center one, second number of the first row. That will be minus 1, minus 1 of that will be 2, 5, 1 and minus 4. 2, 5, 1 and minus 4. The number whichever we are selecting, that row and column should be neglected. The remaining ones will write it. So I'm taking now plus 1. It will be, if I take this row and column, if I neglect this two column, I get 2, 2, 1 and minus. That will be plus 3. You have to do cross multiplication. 4 into 2 will be minus 8, minus of 5 into minus of minus will become plus 5 into 3 is 15, minus 1. 4 into 2 is minus 8, minus of 5 into 1 is 5. This minus is common always. Since here we have minus, it became minus into minus plus. Then next one, plus 1 into 2 into minus 3 is minus 6. 2 3s are 6. Minus of 2 1s are 2. So if you simplify, we get plus 3 into plus 15 minus 8 is 7. Then bigger number sign is plus, so it will be plus 7. Plus 7. Then it is minus 1. Minus 8 minus 5 will be minus 13. Then plus 1. Minus 6 minus 2 will be minus 8. So it will be Plus into plus is plus. 7 3s are 21. Minus into minus is plus. 13 ones are 13. Plus into minus is minus 8. So here we get 21 plus 13 is 34. 34 minus 8 will be 34 minus 8 will be 26. So we got the delta value. Then next step will be same way we'll find now delta x. What will be delta x? So first value will be x, second value will be y, and third value will be z. So in the place of delta x means in the place of x, we'll write this b value, that will be 3 minus 1 2. The remaining two lines will be similar as this determinant, that will be 1 2 minus 3 1 5 and minus 4. So now we have to find the determinant of this term. So it will be same what we have done now. So if you simplify this, we get plus minus plus. So yeah, it will be 3. If you take 3, it is plus 3 equals. I'll do it directly. 2 4s are 8 minus 8. Minus into minus plus. 3 5s are 15. Then minus 1 into. If I take second one, minus 1 into. If I take this. Minus 1 into minus is plus. 4 ones are 4. Then 2 into 5 is 10. 2 5s are 10. Then next one, if you take the third one, it will be plus 1 into this cross multiply. Minus into minus plus. 3 ones are 3 minus 2 2s are 4. So if you simplify, plus 3, 15 minus 8 is 7, minus 1, 4 minus 10 is minus 6, plus 1, 3 minus 4 is minus 1. So it will be 7 3s are 21, minus into minus plus, 6 1s are 6, minus 1. So it will be 27 minus 1 is 26. So delta x will be 26. Same, now next step will be finding delta y. What will be delta y? Second column should be changed with the value what is there for b. That is for y means second value, second column. So y will become 3 minus 1 2. The remaining values will be same, 2, 3, 2, 1, 1, 5 and minus 4. So now simplify, same, find the determinant of this given this term. So here if you take first one, it is first row and first column. So it will be plus 3 into minus plus, 4 ones are 4. Then if you cross multiply this 2, minus 5 2s are 10. Then next one is minus 3. Minus 3, if you take minus 3, you should leave that row and column, that will be 2 into 4 is minus 8, minus of 1 5s are 5. Then if you take the last one, plus 1, if you take plus 1, it will be plus 1 into 2 2s are 4, minus into minus plus, 1 1s are 1. So if you simplify this, 3 into minus 6 minus 3, 8 minus 8 minus 8, 13 plus 1, 5 plus 5. So it will be 3 6 are 18 minus 18, minus into minus plus, 13 3s are 3 3s are 9, 3 1s are 3, 39 plus 5. So yeah, minus 18 plus 44. It will be again 26. Now we will be finding the value of z, delta z. So here delta z will be what? We'll be writing the value of b in the third column, that will be 3 minus 1 2. The remaining two columns will be same as that is in the question. Certainly 3, 2, 1, 1, 2, minus 3. So now again find the determinant. Plus minus plus. First row, if you select, it will be plus 3 into cross multiply. 2 2s are 4, minus into minus plus, plus minus is minus. 3 ones are 3. Minus and minus become plus, but we have already minus. So 3 ones are 3 it is. Then you take minus 1. If you take minus 1, it will be minus 1 into 2 2s are 4, minus into minus plus 1. Then it is last one. We take plus 3, that column and that row we should neglect, plus 3 into, if you cross multiply, minus 6, 2 3s are minus 6, minus of 2 ones are 2. So it will be plus 3, 4 minus 3 is 1, minus 1, 4 plus 1 is 5, plus 3, 6 minus 6 minus 6 minus 2 is minus 8. So it will be 3 minus 5 plus into minus minus, it is 8 3s are 24. So it is 24 minus 29. 29 minus, minus 29 plus 3 is minus 26. So we got the values now for delta x, delta y and delta z. Now what we have to prove? We have to find the value of x, y and z. So x will be delta x divided by delta. That will be 26 divided by 26. That is nothing but 1. Then y will be delta y divided by delta. Delta y is again 26 divided by delta is 26. That will be again 1. Then z is delta z divided by delta. Delta z we got minus 26 divided by 26. This and this get cancelled. It will get minus 1. So x is equals to 1, y is equals to 1 and z is equals to 1. So now we will write A, B, I'm just writing 4 points. Now see here, from A to A we have 0, means there is no connectivity. Then from A to B we have 1. So we have 1 from A to B. We should draw one line. Then from A to C we have one line. That is from A to C we have 1. Then from A to D we don't have any connections. You can go for the next one. B to A we have 0, B to B is also 0, B to C is also 0, B to D is also 0. That means there is no connection for B. Then moving on with the next one, we have C to A is 0, C to B is 1, C to B we have 1, then C to C is 1. C to C means it is a self loop. Then C to D it is 1. So from C to D it is 1. Then C to C is 1 and C to D is 1. Then going with the next one, the last one. D to A is 0, D to B is 2, D to B is 2. So D to B is 1 and D to B it is 1, 2. Okay. Then it is 2. The remaining all are 0. So here this is the graph. We can write the same graph in this way also. In other way, that is A, B, C, A, B, C and A, B, C and D. Now we can just draw a line. This from here to here. It is a loop. Then vertex is here. Then we have from B to C. Then we have from D to B to D to B. We have to D to B. We have to. We can take one from outside also. So this is the graph which we have. Okay. This is called as digraph